Okay, we're going to talk about S12E, increasing and decreasing for derivatives. Okay, so the first thing that we're going to talk about is, well, let's rewrite it in standard form first. Okay, so the first thing we do is we do FOIL. So x times x gives me x squared. X times negative 5 gives me negative 5x. Negative 2 times x gives me minus 2x. And negative 2 times negative 5 is plus 10. Okay, that's called foiling. And we can combine the two middle terms and we get y equals x squared minus 7x plus 10. Okay, there is our equation in standard form. Okay, now our x-intercepts are easy to identify in the original uh, factored form, where the x-intercepts are 2, 2 comma 0, and 5 comma 0. Okay, and so if I'm going to draw a sketch, I can put a 2 there and a 5 there. Okay, the y-intercept is easier to identify. What color am I going to use? The y-intercept is easy to identify in this form. The y-intercept is 0, comma 10. Because the y-intercept is when x is 0, so you plug in 0 and 0 there. The y-intercept is 0, comma 0. Now the axis of symmetry happens halfway in the middle here. So how do we figure that out? So we can either take the average of these two. So for the axis of symmetry, we could do 2 plus 5, average of those two, and then we get 7 divided by 2. So the axis of symmetry is x equals 3.5. Okay, that's the average of those two values. Another way to do axis of symmetry is the axis of symmetry is x equals negative b over 2a. You should remember this from an earlier algebra course, and maybe I think we did this last year too. Negative b over 2a, and that's when you've got y equals ax squared plus bx plus c. Okay, so I could do negative negative 7 divided by 2, and here a is 1, and then you get the same answer. Okay, I've already done B and C, so let's save some time. You might want to hit pause and copy this down. Okay, now I'm going to do questions D, E, and F, which we didn't get time to do in class. So if I'm going to factor this out, I could say f of x equals x, and then we get 3 minus x. I can factor an x out of both terms. So then I can say that for the x-intercepts, happens when at 0 for this guy there, and then what makes this equal to 0 if x is 3. 3 minus 3 is going to be 0. So when x is 0 and when x is 3. Because 3 minus 3, this would have to be a 3 in order to make that equal to 0. The y-intercept is in this form. If we have y equals x squared plus bx plus c. The y-intercept would be the c value. There is no c value, so the y-intercept is 0, 0. Okay. And so notice the squared term here is negative. So that means my graph is pointing down. Because of this negative, it means it's pointing down like that. The axis of symmetry is halfway between 0 and 3. So the axis of symmetry is x equals 1, 1.5. And as I mentioned before, axis of symmetry must be x equals, because that's the equation of a vertical line, x equals 1.5. Okay. And lastly, we're going to draw our function like that. Okay. The next one, we can write that in factored form. So we can write y equals, okay, since it's x squared, I'm going to put an x there and an x there. What two things multiply to 36? And since this is positive, they have to add to give me 12. And it's going to be 6 and 6. 6 times 6 is 36. This is going to be minus, minus. So negative 6 times negative 6, sorry, negative 6 times x gives me negative 6x. And this x times negative 6 gives me negative 6x. And they add up to give me 12x. Okay. And, okay, so what happens if the root is twice? That means our parabola crosses the x-axis at one spot, not two. So the x-intercept is when x is 6. So at 6, we've got our x-intercept. So when these are the same, that means our parabola only touches at one spot. Okay, the x squared is positive, so our parabola points up. Okay, the y-intercept is the c value when x is 0, so the y-intercept is 0, 36 coordinate. Okay. Okay. I'll have our drawing go through there. Sure. Okay. There are no two numbers that multiply evenly to subtract and give me this. So I'm going to have to do this one on the calculator. So, I type in x squared plus x minus 7, and make sure you do zoom 6 gets me the standard 10 by 10 window, and we've got our graph here. So, well, first of all, we can't factor it out. Our y-intercept, we can automatically say is 0, negative 7. So it crosses the y-axis here at 0, negative 7. Okay. Now, let's find out the x-intercepts here. So second trace, and then we can find the 0. And then I need to go to the left side of this intersection. Okay, now I'm to the left of it. I hit enter. And then I need to go to the right side of it. I'm to the right of the 0. I hit enter. It says guess. I hit enter. And this intersection is negative 3.19. And what's the other one? Second trace. We want to find a 0. Enter. I'm going to arrow over to the left side of that 0. I hit enter. Go over to the right side. I hit enter. Enter. And that 0 is 2.19. 2.19. Okay, there are x-intercepts. And it looks like our axis of symmetry is over here somewhere. So the axis of symmetry is going to happen at that minimum value. So second trace, I want to find the minimum. So I go down to 3, I hit enter. I need to go to the left side of the minimum. Okay, there, I hit enter. I go to the right side of the minimum. I hit enter. It says guess, I hit enter. And my minimum is negative 0.5. So the axis of symmetry is x equals negative 0.5. Okay, you might want to hit pause to rewind some of this. Okay, so now let's just talk through this other part. So a function is increasing. As I go to the right, it's going up. And a function is decreasing. As I go to the right, it's going down. So on this handout, through the whole thing, I've anything that's increasing as I go to the right, I've colored in pink. Anything that's decreasing as I go to the right, I've colored in blue. Okay, so in this graph here, from here down to here, it keeps going down. So it's decreasing, and at 0 is when it kind of changes, and then it starts increasing. So this is called a turning point. We'll talk more about that on the next lesson. And so if I want to draw a sign diagram, here we have negative. Our derivative is negative here. If I plug in a negative value in for x, we're going to get a negative value for our derivative. Over here, if I plug in a positive value x, 2 times the positive value is going to give me a positive value here. Let's talk to these two before we do the next problems. So here, my function is negative x squared. So my derivative is negative 2x. If I plug in a negative number in for x, negative 2 times a negative number is going to give me a positive number. Whenever the derivative is positive, that means we have an increasing function. Now, if I have a positive value for x, then in the function, if I put negative 2 times a positive value, that's going to give me a negative, right? Negative 2 times a positive value is going to give me negative. So I know it's decreasing if I put positive values in for x. Now this negative here does not mean, this is not the same, this is not equal to negative x squared. This is not the same. Okay, so this means you're going to take it squared and then make it negative, and that's why it's pointing down. Okay, here I have 1 over x squared, and the graph looks like this. The difference between the sign diagram here is we have a dotted line here, and when you have a dotted line here, it means the graph will never be equal to 0 because you can't have 1 over 0. Now let's talk about the answers to the problems here. Okay, so from here to here, when x is less than negative 1 and when x is greater than 2, we've got increasing functions. And the graph is decreasing when it's between negative 1 and 2. Okay, you may want to check your answers. Hit pause. Okay, next page. Okay, so here I've got the function. Look at the graph. Tell me when it's increasing and decreasing. So between when x is less than 1 and when x is greater than 3, and it's decreasing between 1 and 3. Now, check your answer by taking the derivative and constructing a sign diagram. So if I take the derivative of x cubed minus 6x squared plus 9x plus 2, I end up with this. And then I see, oh, look, I can factor out the 3. And then I get x squared minus 4x plus 3. And then I say, oh, look, I can factor this out. What two things multiply to give me 3? And add, because it's plus, add to give me 4. And it's going to be negative 1 times negative 3. So I can factor it out like this. And so I know that one of my zeros is 1, and one of the zeros here is 3. Okay, so I know that I have a turning point at 1 and a turning point at 3. Okay. Now, one way you can check here, you can check, and I could say, let's put a number less than 1, like 0, for example. If I plug in 0 here, I have 3 times 0 minus 1 times 0 minus 3. Okay, so 3 times negative 1 times negative 3, a positive times a negative is going to give me a positive value, isn't it? Okay, let's pick a number between 1 and 3. How about 2? Right? Okay, so I can check. I can say we've got 3 times 2 minus 1 times 2 minus 3, right? So we're checking here. So this is 3 times 1 times negative 1, right? A positive times a negative is going to give me a negative answer. Lastly, something bigger than 3. So let's try 4. So then I would have 3 times 4 minus 1 times 4 minus 3. So this is a positive times a positive times a positive, which is going to give me a positive. So this is one way you can check to see, does your sign diagram make sense? Okay, let's look at number 3 now. Okay, find the first derivative. Okay, so 3x squared minus 12x. Okay, this factors out to be x. I can factor out the 3. And then x minus 4. So we know at 0 and at 4 we've got a turning point. So this point right here is at 4. So it's increasing when x is less than 0 and when x is greater than 4. And it's decreasing between 0 and 4. Okay, last page. Here we go. Okay, find the interval where it's increasing or decreasing. All I need to do is take the derivative. The derivative of 2x plus 1 is going to be 2. So it's always going to be increasing. Okay, this says x is an element of all real numbers. Okay, if I take the derivative of this, I get negative 3. So we know the slope is negative 3, so this is always decreasing. If I take the derivative of this, I end up with 2x. This is just like the one on the front page. Okay. Now, there's two ways to do this. Okay, take the derivative. Okay, we took the derivative. Okay, use technology to find the values when the derivative is equal to 0. So to make the derivative equal to 0, I type this equation in. Let's do that right now. So negative 12x squared plus 30x plus 18. Okay, graph, and we're going to see it's probably going to cut off the page, right? So we need to change our window. Let's change our y max to something bigger. I don't know, 40. Is that big enough? Sure, that's big enough. Okay, so I want to find this 0 right there. So I'm going to hit second trace 0, second trace 0. And the left bound, I need to go to the left of this intersection, so I have to left arrow. Okay, I'm to the left, I hit enter. Now I need to go right bound, I have to enter the right arrow. Okay, I'm to the right of this intersection, I hit enter. Guess I hit enter, and it tells me that 0 is at -5. Same thing again. Second trace, 2 for 0, and now I want to get closer here. So here I'm on the right side of the 0, I hit enter. Now I need to get to the right side of the 0, I hit enter. Guess I hit enter, and it tells me that 0 is at 3. Okay. So now that I know that this here is at -0.5, and this here is at 3, I could say it's increasing from -0.5 to 3, and it's decreasing when it's less than -0.5 or when it's when x is greater than 3. You might want to hit pause to copy this. Same thing for this one here. I took the derivative, I factored out the 3, but that really didn't help because to figure out these here, I needed to, I could do the derivative. Now another thing we could have done is I could have figured out this point by graphing the original function. This is an alternative way that I can click clear. Let's graph the original one. We've got x cubed minus 6x squared plus 3x minus 1. Okay, just typed in the equation. Looks like we need to change our window, the y max and min. So let's change the y min to -30. Okay. Okay. So one way to get some points here, I can do second graph, and that gets me some points, and that's where I got these points to get to draw a sketch of my graph. You're going to have to do second graph to get a table to help you with a sketch. You'll have to do this on the test to be able to get a sketch of your drawing. So I want to figure out where this point is right here at the top. So if I graph, here's where it is. It's somewhere in there. So I need to second trace. I'm going to find, this is a maximum, right? So I hit enter for maximum. So I can go here, it's on the left side, I hit enter. I go over here to the right side, I hit enter, enter, and I get 0.267, which is the value I got here. 79, so I guess 68. And I do the same thing process here. Second trace, minimum, enter. I'm going to go left bound, right bound, enter, enter, and then we get 3.73. Okay, you might want to hit pause, rewind. Hope this helps.